Hello student, welcome in lecture 2 in communication engineering KEC 401 subject. So, today we will go through the basic principles of communication, especially amplitude modulation, and these are the contents which we will cover today. Some historical review, then basic elements of communication system, then passband, baseband and passband signals and systems, then different frequency bands which we use in our communication system, then modulation and demodulation process, why we need modulation and different types of modulation, and finally, we will go through a brief about the amplitude modulation. So, this slide shows you the historical review. In 1837, Samuel Morse basically transmit the information in form of dash and dots. Then in 1864, Maxwell gives his 4 Maxwell equations, and those Maxwell equations were used to formulate the wave equations, and because of these wave equation, then Hertz was basically gives the demonstration of wave character of the electromagnetic radiation. And then 1995, Marconi first transmitted information through wirelessly, and around 1920 short waves were discovered and amplitude modulation was commercially utilized for the transmission. Although the concept of amplitude modulation was demonstrated in somewhere around 1905, but commercially it was started in 1920. Then Edwin Armstrong gave the concept of frequency modulation, which is very useful in noisy environment in 1933, and totally somewhere around 1936 this FM frequency modulation commercially utilized. Then 1992 and 2001 2G and 3G they came into the market, and nowadays 5G and 6G are basically in demand. So, this slide shows you the basic communication system, basic model. So, in any communication system we have these blocks: the input transducer, transmitter, channel, receiver, output transducer, and the channel is influenced by or affected by the distortion, noise. So, noise may be external noise, atmospheric noise, for example, atmospheric noise. So, the channel will be affected by the atmospheric noise if the channel is wireless, otherwise if it is a guided medium, then it is affected by the guided noise. Receiver is also in fact affected by the internal noise. So, out of these blocks there are only 3 elements of basic communication system. So, if someone asks you what are the elements of communication system, so only the transmitter, the channel and the receiver, these makes you the elements of any communication system. So, transmitter, channel, receiver gives you the elements of communication system. So, the function of input transmitter is to convert any audio, video, raw audio, video, text into electrical format. So, the output of this input transducer is electrical signal. This electrical signal is converted into a suitable format by this transmitter, so that this formatted signal by the transmitter can easily pass on through the channel. The channel behaves as a system. It takes the transmitted signal, and obviously in communication system this channel is not LTI or LSI channel, linear time invariant channel, because the channel is not only varying with respect to time, its behavior is unpredictable. So, it is also not a linear channel. So, this is normally non-linear time variant channel. So, because of this property, this channel will change the characteristic of this transmitted signal and pass through it. The channel can also behave as a filter So, it will filter out some frequency components from this transmitted signal and passes some of the frequency component. During this transmission, this information is corrupted by the noise also. The function of the receiver is to receive the transmitted information through the channel, process it, try to find out the originally transmitted signal, then the output of the receiver, output signal, process signal is again converted back into electrical signal. So, these are the function of different blocks of the communication system. So, baseband and passband signal. So, the signal at the input of the transmitter is known as baseband signal. So, the signal before the transmitter or at the transmitter input is known as baseband signal, while the signal at the output of the transmitter is known as transmitted signal or passband signal. So, what are the differences between the baseband signal and passband signal? So, my speech in raw form without transmitting through the transmitter is a baseband signal. So, in my speech the lowest frequency component practically we use is 300 hertz and the maximum frequency component is 3.5 kilohertz. So, roughly the bandwidth is somewhere around 3 kilohertz. So, this speech is basically a baseband signal. So, baseband signal is something having a very low frequency components, low range frequency components. Most of the frequency components are basically situated or placed nearby 0 hertz in frequency domain. When we modify this baseband signal by some property like modulation inside the transmitter, it becomes passband signal. So, passband signal is nothing but the baseband signal, but the spectrum of this baseband signal is translated or shifted to a higher frequency range. So, it means the passband signal contains the same frequency component, but they are translated at a higher frequency range. So, why we are converting this baseband signal to passband signal? Because the baseband signal have low power. So, they cannot be transmitted to a longer distance, while when we modify it through the modulation process, we will see it what is modulation demodulation by the transmitter, then the output of this transmitter, that means passband signal, can be transmitted to a longer distance. So, the passband signal will feel less attenuation when it passes through the channel, while the baseband signal will feel larger attenuation when passes through the channel. So, we always prefer to transmit passband signal rather baseband signal. So, these are the differences. So, baseband signal refers to the signal having operational frequency band or frequency component very close to 0 hertz. Baseband signal cannot be transmitted to a longer distance. It is suitable for generally short distance communication, for example, a telephone line in which we never use any kind of modulation is known as baseband, while passband signal have the frequency component at higher frequency range and their energy or the power is also high. So, that they can be transmitted to a longer distance. So, this slide shows you the frequency band for communication. So, you can see here the band starts from very low frequency VLF, then low frequency, medium frequency, high frequency, very high frequency, ultra high frequency, super high, extra high frequency, infrared and visible light. So, you can see the twisted pair cable are used and coaxial cables are used in this band from VLF to till UHF. Amplitude modulation, which we will cover in later slides, basically lying in somewhere around mid frequency range. So, the range of this amplitude modulation is from 535 megahertz to 535 kilohertz to 1605 kilohertz range. So, kilohertz range is lying somewhere around this low frequency range, this range. So, amplitude modulation is basically lying between 535 kilohertz range to 1605 kilohertz range, while the frequency modulation lies in the range of 88 megahertz to 108 megahertz. So, you can see the megahertz range lie somewhere around HF and VHF range. So, VHF and UHF range are used for TV broadcasting or satellite communication, video transmission, while this optical transmission, optical fiber communication are used somewhere around 300 terahertz range. So, it means the optical fiber communication gives you the highest available bandwidth, and hence the data transmission rate is high in case of optical fiber communication. So, now we will understand the concept of modulation and demodulation. So, modulation, so whenever we transmit our information, we have the information, suppose the information is represented by MT in time domain. I have a block which is generally known as product modulator or multiplier, you can say product modulator, and there is another signal which is known as carrier signal, and the output of this signal is known as modulated signal. So, this product modulator oscillator which generates a carrier signal, these are the part of the transmitter. This information signal MT is also known as we have discussed earlier, baseband signal, while this modulated signal is also known as passband signal. This baseband signal is also known as modulating signal. So, a signal without modulation, is known as modulating signal. A signal after modulation is known as modulated signal or passband signal. So, a modulating signal, baseband signal, information signal, these are the same thing, while modulated signal and passband signal are the same thing. So, carrier signal is basically a kind of periodic signal, while the information MT is not a periodic signal, it is kind of random signal or random information. You cannot predict the next value of this information with respect to time. So, this carrier signal, there are certain conditions when we go for modulation. So, modulation is basically the process in which we change some characteristic of the baseband signal, modulating signal, information signal by using a carrier signal, this carrier signal. So, when some characteristic of this carrier signal, if I represent this carrier signal by mathematical formulation A cos omega c t, or suppose AC cos omega c t, where AC is the carrier amplitude of this carrier signal, while omega c is the carrier of the frequency of the carrier signal. We have to take the condition that the amplitude of the carrier signal AC must be greater than the amplitude of the modulating signal. Means for the modulation process, AC must be very greater than the amplitude of the maximum amplitude of the MT signal. Also, the carrier frequency must be very greater than the maximum frequency component omega m contained by the information MT. So, omega m is the maximum frequency component in the information which you want to transmit. For example, if I take an example of my speech, so speech has maximum frequency component of 3.5 kilohertz. So, omega m is 3.5 kilohertz. So, these are the two conditions which must be followed when you go for modulation. So, now we will define the definition of modulation. So, a modulation is something, a modulation is a process in which some characteristic of this carrier signal is changed in accordance with the some characteristic of this information. So, what are the characteristics of carrier signal? So, any signal, not only carrier signal, they have only two characteristics or three characteristics. One is amplitude, another is frequency, and another is a phase. If I take omega c t plus theta, so theta is your phase and omega c is your carrier frequency. So, if we change, if the characteristic of the carrier signal, either amplitude, frequency or phase is changed in accordance with the instantaneous amplitude. Please see the importance of this empty signal. So, amplitude of this empty signal will change instantaneously some of the characteristic of this carrier signal. Then we say that there is a modulation. So, modulation basically is the term which is used for carrier signal. If we change the characteristic of the carrier signal by using the information, we say that this is the modulation. The reverse process at the receiver side is known as demodulation. So, modulation is the process which always takes place at the transmitter side, while demodulation is the process which always takes place at the receiver side. So, when we change the characteristic of the carrier signal by using a modulating signal at the transmitter side, so this is known as modulation. When we fetch out the information from the carrier signal at the receiver side, this is known as demodulation. So, why we need the modulation, or what are the advantage of modulation? So, these are the advantages of modulation. So, first advantage is or need is practicality of antenna. So, generally whatever antenna we design, its dimension must be in terms of lambda by 2, its dimension must be in terms of lambda by 2 or lambda by 4. So, suppose we take the dimension means the height, the width, the length, these are the dimension of the antenna. So, these length, width, height must be in terms of lambda by 4. So, where lambda is the wavelength we transmit during the transmission. So, lambda is given by c upon f, where c is the velocity of light 3 into 10 to the power 8 meter per second, and f is the transmitted frequency. What frequency? Generally this is basically the frequency which the transmitter is transmitting without modulation or without modulation. So, suppose if we not go for modulation, for example, if I take my speech signal which contains frequency component between 300 hertz to 3.5 kilohertz without modulation. So, this range is basically the baseband range, baseband information or modulating signal. So, this range contains infinite frequency component between 300 hertz to 3.5 kilohertz. So, if I use an antenna whose dimension is, or suppose whose height is lambda by 4, means c upon 4 f, then you can see the height is inversely proportional to 1 upon f, because c and 4 are constant. So, if I transmit a baseband signal whose all frequency components are lying near to 0 hertz, means having a very low range of frequencies, suppose for example, speech signal 300 hertz to 3.5 kilohertz, then the required height or length or width of the antenna is very high. Suppose if I put 300 hertz here in this formula C upon 4. So, height required for the antenna is 3 into 10 to the power 8 divided by 4 into 300. So, this is a very high, somewhere around kilometers height of the antenna. So, practically this height of antenna is not possible. If I use a highest frequency component in my speech to transmit 3.5 kilohertz. So, 3 into 10 to the power 8, 3.5 kilohertz, then again I need a very large height or length or size of antenna. So, practically this is not possible, that the size of the antenna is very large. So, if we transmit, means if we transmit the baseband signal without modulation, so we require large size of antenna. Now, if we go for modulation, if we modulate this signal by using a carrier signal, suppose the frequency of the carrier is 20 gigahertz. If all these frequency components are superimposed over this 20 gigahertz carrier frequency, so obviously the modulated signal will have the lowest frequency component 300 hertz plus 20 gigahertz. This is the lowest frequency range in modulated signal, while the highest frequency component will be 3.5 kilohertz plus 3.5 kilohertz per 20 gigahertz. So, you can see that the lowest frequency is almost 20 kilohertz, 20 gigahertz, and the highest frequency is also almost 20 gigahertz, because this 300 hertz compared to this 20 gigahertz and 3.5 kilohertz with respect to 20 gigahertz is almost negligible. So, the size or height of the antenna I require is 3 into 10 to the power 8 divided by 4 into 20 gigahertz. Giga means 10 to the power 9. So, the height of the antenna is somewhere around in millimeter, or the length or size, length or width or height of the antenna is somewhere around millimeter, which is a practical, which is practically feasible. So, this is the reason why we need a modulation for size of antenna. So, if we transmit our information without modulation, so we require large size of antenna, or if we transmit with modulation, then we require a very small size of antenna. Now, what is narrowbanding? So, narrowbanding means, you can see here, if I transmit my information without modulation. So, if I transmit 300 hertz frequency component, lowest frequency component in my speech, so I require a kilometer size of antenna, height of antenna, and simultaneously the highest frequency component 3.5 kilohertz. For this 3.5 kilohertz, the height of the antenna is different. It means, if I transmit all the frequency component between this 300 hertz to 3.5 kilohertz range, so I need different height of or size of antenna to transmit all the frequency component. So, practically that is also not possible. You cannot design an antenna whose length or size varies with respect to different frequency components from between 300 hertz to 3.5 kilohertz. But if I modulate this signal using 20 gigahertz carrier signal, so you can see the lowest frequency as well as the highest frequency component is almost 20 gigahertz. So, practically you can transmit all these frequency component between 300 hertz to 3.5 kilohertz after modulation, means 300 hertz plus 20 gigahertz and 3.5 kilohertz to plus 20 gigahertz range, without changing the size of the antenna. So, this is narrowbanding. So, narrowbanding basically given by the ratio. So, this ratio highest frequency range divided by lowest frequency range means this is the highest and this one is the lowest. So, if I transmit the narrowbanding means if I transmit my information without modulation. So, what should be the ratio? Highest frequency component or lowest frequency, you can take lowest frequency component also. So, 3.5 kilohertz divided by 300 hertz, this ratio is large, roughly 1000:1 if I am not wrong, and if I transmit the same information after modulation. So, the narrowbanding ratio will be 20 gigahertz divided by 20 gigahertz, the ratio is 1:1. So, it means for transmitting the lowest frequency component and the highest frequency component without basebands, without modulation means if you are transmitting the baseband signal. So, you have to change the height of the antenna for different frequency component in the range between 300 hertz to 3.5 kilohertz. But if you modulate it, so almost the lowest frequency component and the highest frequency component are same. So, the ratio is 1:1. So, you need not require to change the height of the antenna for different frequency component. Now, multiplexing. So, if I transmit my baseband signal without modulation, so what will happen? Because suppose for example, if I ask a question in my class and all the students they will simultaneously try to give my answer. So, there will be a noise in the class, there will be a chaos inside the class, because everyone speech have the same frequency range between 300 hertz to 3.5 kilohertz. So, all the students they will start to convey their information in the same frequency range, there will be a mixing of each and every one voice. So, I will not be able to understand what the students are saying. So, this is basically without modulation. But if I suppose I have 2 students whose frequency range are F1 and F2, I translate this first student frequency range to a different carrier frequency range by using carrier frequency 20 gigahertz, and another student frequency range, and obviously F1 and F2 are same because their frequency components are lying between 300 hertz to 3.5 kilohertz. So, it means we have translated the speech of the 2 different students to a different frequency range, hence they will never overlap when they will ask me a question simultaneously. So, multiplexing is the process in which we shift the baseband information, different baseband information in different frequency range, so that they cannot mix with respect to each other. The last two properties are ease of radiation, and so when we go for modulation, so whatever radiation beam an antenna transmit, it becomes narrow and narrow, beam width will be small. When we go for modulation, without modulation, most of the energy will dissipate in the atmosphere, and at the receiver side signal to noise ratio will be low. But when we go for modulation, signal to noise ratio will be high and the beam width will be low, hence the signal can be transmitted to a longer distance. So, these are the different types of modulation schemes. Modulation schemes are categorized in 2 parts. One is continuous wave modulation, another is pulse modulation schemes. The continuous time modulation schemes are further categorized in 2 parts. One is amplitude modulation, another is angle modulation. Angle modulation is further categorized in 2 parts, frequency modulation and phase modulation. Pulse modulation are categorized in 2 parts, digital modulation and analog modulation. Analog modulation further are categorized in 3 parts, pulse width, pulse amplitude and pulse width modulation. while digital modulation are categorized in PCM, delta modulation and adaptive delta modulation. So, we will go through these types of modulation in next lectures. So, these are the references you can use for your further study. Thank you for listening my lecture. We will meet again in next lecture.